Hi everybody, today we're doing an introduction to graph theory. We're going to go over the basic terminology and concepts you're going to need as we go throughout this unit. We use a graph to model relationships between objects. A graph consists of two parts, a set of vertices and a set of edges. Vertices represent the objects in a graph. Depending on the application, a vertex might represent a person in a social network, a location in a map, or a computer that's part of a network. We usually label vertices with symbols like v sub 1, v sub 2, v sub 3, or simply use letters like A, B, and C. On their own, vertices don't tell us much. What matters is how the vertices are connected. Edges describe connections between pairs of vertices. Whenever two vertices are connected by an edge, we call them adjacent. Let's look at an example of a graph. In this graph, we have four vertices, v1, v2, v3, and v4. We also have four edges. One from v1 to v2, one from v1 to v4, one from v1 to v3, and then one from v3 to v4. Here, we would say v1 is adjacent to v2, v3, and v4, but if we looked at v2, it is only adjacent to v1. Let's talk about a few distinctions in graph theory that are different than how you've used points in algebra and in geometry. When we have an edge that connects a vertex to itself, we call it a loop. Vertices that have more than one edge connecting them are said to have parallel edges. Notice that edges in a graph don't have to be straight. We can have lines, curves, or circles. Let's look at how we can numerically define a graph. The degree of a vertex is the number of edges connected to the vertex. Loops are always going to count as 2. So let's take this graph and find the degree of each vertex. When I look at vertex A, it has a loop and it has an edge from A to D. That gives us a total degree of 3. B has two edges connecting it to C, so that's a total of 2. C is also connected to B twice, but it's also connected to D, which says C has a degree of 3. D is connected to C and A, so that gives us a degree of 2. If we add up 3, 2, 3, and 2, we get a total of 10. As a summary, we can say this graph has 4 vertices, 5 edges, and a total of 10 degrees. Let's find the degree of each vertex in this second graph. A is only connected to D, so that's a degree of 1. B is also only connected to D, which gives it a degree of 1. And C is only connected to D, which gives it a degree of 1. But because D is connected to A, B, and C, its degree is 3. If I add together 1, 1, 1, and 3, I get a total of 6. So this summary says we have 4 vertices, 3 edges, and a total of 6 degrees. And what I want you to see is there's a connection between the number of edges and the total degrees in the graph. The total degrees in a graph is always equal to twice the number of edges. Because of that, all graphs are going to have an even number of odd degree vertices. So let's use what we learned to draw a graph. We're given a graph has 5 vertices, A, B, C, D, and E. The degree of A is 3, the degree of B is 3, the degree of C is 2, the degree of D is 2, and the degree of E is 2. The first question says determine the total degrees of the graph. So we need to add 3, 3, 2, 2, and 2, which is a total of 12. Then we want to use the total degrees to determine the number of edges in the graph. We just learned that the total degrees in the graph is 2 times the number of edges. So if we divide 12 by 2, we're going to get that the number of edges is 6. Now we're going to draw a graph to represent what we were given. There are more than one answer, so we're going to do this twice. We'll start by drawing our vertices. We have A, B, C, D, and E. A is supposed to have a degree of 3, so let's connect A to B, C, and D. B is also supposed to have a degree of 3. It's already connected to A, so we need to connect it to 2 more vertices. Let's connect it to E and C. C is supposed to have a degree of 2, and it already does. It's connected to A and B. When we look at our graph right now, notice that we have 5 edges already drawn. We're supposed to have 6 altogether, which means we can only add 1 more. So we need to add an edge from D to E. That way, D and E will both have a degree of 2. I want to show you that this drawing doesn't have to be unique, so let's draw it again. I'm going to start again with A, and to give it a degree of 3, I'm going to connect it to B, C, and D. But this time, instead of connecting B back to other vertices, I'm going to connect it to itself. Now B has a degree of 3. I need C to have a degree of 2, so I need to connect it to one more vertex, so let's connect C to E. D and E also need to have a degree of 2, so let's connect them. This graph didn't tell us which vertices were connected, so we were able to draw it in different ways. What mattered was how many connections we had and how many edges were in the graph.